Okay.
So,
Thank you, Shelby. So, 5.7, dividing. Last thing in this chapter. This will be a great exam. This will be an easy exam. You guys will all be able to get A's on this one. Boost your grade a little bit. What's that? This is the last section on the exam. Yeah, is this one. This won't be hard. Maybe it looks weird at first, but I'll show you the easy. So it's dividing. We've been doing a bunch of multiplying, right? Now we're going to divide. And notice that both of those are over the x. Like the bar goes all the way, so they're both over the x. They're both over the x. So what that means is that you can just like let me tie it into what we've already done. If you had one x in the front, don't write this down. This isn't what we have. But if you had one x in the front, what would you do? Yeah, that one x would go to both, huh? Well, it's the same way when you divide. He's just going to divide both. It's kind of like distribution. You're just going to go 12x to the 7 over the x and 2x squared over the x. That makes sense? Since he's under both with the big bar, he just distributes himself underneath to both. It's just common denominator, really. That's all it is, right? If you could just hold the door all the way open, Shelby, and then just fan. All right. So now, good so far? So you just distribute dividing like you distribute multiplying. Now, what do we do from there? What is this one? What is 12x to the 7th over x?
It's
What do you do?
12x 6.
Yeah, because there's a 1 down here, right? Invisible 1 power. Remember we learned when they're vertical, powers subtract. Remember that? We had that whole section on that. So that's 12x to the 6th. Same thing over here. There's a 1. They're vertical. What's it going to be for the other one?
Only x plus x.
2 regular x. X to the 1, regular x. You're right. Does that make sense? The powers subtract when they're vertical, huh? 2 minus 1 is 1. Done.
Okay, but in that one, we have to go individual. Not
Yeah,
like
each one.
Not take the whole thing.
Right, individual. Exactly. For each one. Just like
break
multiply. Just like it's high fives for the multiplying, it's high fives for the dividing. It goes to each one.
Oh, okay.
Same thing. See how it's exactly the same? It's just dividing now instead of multiplying. So you subtract powers instead of add. But it still goes to each one, just like the multiplying went to each one.
Okay.
Exactly the same. See that? All right. So it's the thing. So that 7 is going to go under each one separately, right? Distribute from the bottom. Make 4 separate little fractions. And then just divide. Okay, so it's going to divide each of them, isn't it? That 7's going to go into each one. So I'm just going to do them all. Is that okay if I don't? I mean, I guess you could just write a 7, 7, 7, 7. I mean, that's really what it's going to do. And then 7 goes into 42 6 times. It's not going to mess with the powers at all because it doesn't have an x down there, huh?
Just number.
So it's just numbers, yeah. So just 6x to the 3rd, 7 into 63 9 times, 9x squared. 7 into 28 4 times, and 7 into 14 2 times. There it is. We good there? This all making sense? Questions on that one? All right, so it's just the same thing, isn't it? We're just dividing. So try number 3. The same kind of thing. That 5p is going to go underneath each one separately. Okay, so we make it 2 separate, huh? So 25p to the 8th over 5p plus 15p to the 7th over 5p. We good so far? Like that. And then we cancel. 5 goes into 25 5 times. And what do you do with the powers?
Subtract.
They're going to subtract. Remember, when letters are vertical, the powers subtract, don't they? 8 minus 1, p to the 7, huh?
7,
Good, and then plus, and then the next one, 5 into 15,
3,
3 times, and 7 minus 1,
P6.
6. Good? Not too bad? Questions? Number 4, same thing. You got to write 2 of them. Write 2 separate fractions. And show you what's going on with this one. So they want me to go minus 18x to the 4th over 15x to the 5th plus 90x to the 5th over 15x to the 5th. So far so good. I just put that 15x to the 5th under both of them. I distributed it, right? So now we have 2 separate fractions. So how do we deal with the first one? Well, the first one, 18 and 15 are both divisible by 3. I just reduce it like a normal fraction is reduced. Just divide by 3, top and bottom. And you get negative 6 over 5. And now what happens with the x's? Where are there more? Yeah, on the bottom, for the first fraction anyway. There's more on the bottom, 1 more. So the subtraction will leave 1 on the bottom. None on the top. Just x on the bottom. Is that good? And then, everybody make sense out of that? That's because what it really, x to the 5th, you know what x to the 5th really means. It means 5 of them, huh? And x to the 4th means 4 of them. They cancel, 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 cancel. And what's left over? 1 on the bottom. That's really what's happening there when we do that subtraction rule. Right? There's a little x war. They're canceling each other out. Right? There's 1 left over on the bottom.
I think it's easier to do it that way for fractions with exponents that way.
Just to show them?
Just to show them.
Yeah. Yeah. Yeah, because sometimes the rules can get confusing, like do you start with the top or do you start with the bottom? Yeah. Yeah, in general, though, if you do want to, and sometimes the rules can be nice, you start wherever the bigger one is, huh? So wherever the bigger one is, in this case the bottom, 5 minus 4, 1, or just plain x on the bottom. Okay, next fraction. Plus, now, on this one, 15 just straight out goes into 90, doesn't it? 6 times.
6.
Okay, and what happens with the x to the 5th over x to the 5th?
They cancel.
Just bye-bye. It's just 6. And so there's the answer. Minus 6 over 5x plus 6. On the multiple choice test we'll take next week, when you guys are all going to get A's on maybe, you'll probably get some good grades. Sometimes they'll try to fool you like this. They'll go like that. That's different, huh? Do you see how that's different than what we have?
It is different.
What's different? Why is that not the same? Why would you not grab that option? Good. See how the 6 over here is not over the 5x anymore. And they put it back over.
They put on the same, yeah.
That's not the same, right? Everybody good with that? The 6 is alone. He's not over a 5x. He's not part of a fraction anymore.
It become a completely different number.
Yeah, completely different, separate thing. It's not over the 5. This would be different, right? Watch out for that. They try to pop them back up there and try to fool you with that. The publishers' questions do that a lot, I've noticed over the years. All right, so let's try the same thing. So take that denominator, put it under all 3. Put it under 5x to the 3rd. Put that under all 3. Make it 3 separate fractions. Okay, let's see. So 3 separate fractions. Let me come up here. So minus 15x to the 6th over 5x to the 3rd plus 25 x to the 4th over 5x cubed minus 20 over 5x cubed. So first off, the 5x cubed distributes himself to the bottom of all 3. Bottom, bottom, bottom. Okay. Now, what do? We divide the numbers, subtract the powers. See how it's exactly the opposite? Remember before we were saying multiply numbers, add powers. Now we're dividing numbers, subtracting powers, aren't we? So 5 goes into 15 3 times. Minus 3. And what's going to happen with the x's? Yeah, wherever the bigger one is, that's where the leftovers. The bigger's on top, leftovers on top. Bigger on the bottom, on the bottom. So the bigger's on the top, x6 minus x3. So it's going to be x to the third on the top. Good? And that means on the top. When I write it that way, it's really over 1. I'm not going to show that. But I'm just letting you know it's on the top when you write it that way, right? Okay. Plus the next one. 5 into 25. 5 times. The 5's on the top. Subtract the powers. Where's the bigger one? On the top. X to the 1 or just x on the top, meaning over 1. Minus now 5 into 20 4 times. So the bigger number is on the top, but where's the bigger x? The only x on the bottom. So he must stay down like that. Does that make sense what happened there? So wherever the bigger stuff is, that's where it ends up. So if the bigger number's on the top, the number's on the top, the bigger x is on the bottom, the x is on the bottom. It would be wrong to write it like this. This is the mistake I've seen over the years, just to write that. But that's not right because you just suddenly put that x cubed. That's really over 1, huh? You just suddenly put that x cubed on the top. He was always on the bottom, and he cannot jump to the top like that. So he must stay on the bottom. And so that's the answer. You know what the publisher thing I've seen over the years, what they try to do with that? Is they'll try to sucker you with this answer. They'll say, on the multiple choice test, they'll go like that, and then they'll put the x cubed all the way. That's different, right? Don't grab that answer. That's not the same thing. The x cubed is only under the last one. To put the bar all the way is to put x cubes under those guys too. That's not right. Right? That'd be different. Right? Don't grab that option when they try that stuff. Right? All right. Good. How about one more? You up for one more? Okay, so minus 15 x to the fourth goes underneath all three. So I'm going to come up here. So I'm going to get 15x to the fourth over minus 15x to the fourth. So this is the minus in the middle here. 10x cubed over minus 15x to the fourth. Plus, that's the plus here, 7 over minus 15x to the fourth. Good so far? Is that making sense so far? So we just distribute the minus 15x to the fourth. It divides all three. Now, what does that first one end up coming out?
One.
Yeah, does everybody see it's negative 1? Because this is the same thing over itself. Whenever you divide the same thing over itself, just think about like 3 over 3. What is it? It's 1, and if one of them is negative, it's negative 1, isn't it? Because positive over negative is negative. So yeah, so this is all just going to be a big old negative 1. Does everybody see that? Next, what are you going to do? Now, how do the signs work? The sign that's down here in the bottom, to be on a fraction, a minus sign, top, bottom, front's all the same thing, huh? So these two minuses basically get together. They're really the same place to be plus, don't they? Does that make sense? Those two minuses. Doesn't matter that one's in the bottom, one's in the front, whatever. They're all in the same world. Two minuses make plus. And then, I'm kind of erasing that 1 there. What do we do with 10 over 15? Yeah, what goes into 10 and 15?
5.
So I divide by 5, and I'm going to get what? 2 over 3, yeah. And then what happens with the x's on that middle fraction?
Leave it on the bottom.
1x, x to the 1, or just x on the bottom because 4 minus 3. And the answer ends up where the bigger one is, the bottom. Next one, plus and negative. Just negative, huh? Just put that in the front. Doesn't matter where, just one positive, one negative is negative. And there's nothing you can do with that fraction, huh? Nothing reduces, nothing goes on. That's just it right there. Does that make sense on that? We good? Questions?